Okay, so you should be able to tell from my drawing that this is an isosceles triangle because it has two angles that are equal, and of course at least two equal sides. Okay, these angles here are called the base angles. Those are the angles that are equal in an isosceles triangle. Now, the base angles lie on the base side. So this side here is called a base, not because it's the bottom of the triangle like many of you think, but because it's the non-equal side. So your base side is the non-equal side. And then that is where your base angles lie, then, is on the base. This point up here is going to be your vertex. Now, what we're focusing on right now with the isosceles triangle is if I were to draw a line through my other angle, my non-base angle here, all the way down through my base side. Now, there are many theorems in the book, and I'm going to break them down for you. Pretty much all the theorems are saying that this line here has 4 jobs. Okay, it has 4 main purposes. The first is the pretty obvious. Whenever you have a line that splits an object completely in half so that it's a mirror image on each side, that's a symmetry line, or line of symmetry, which I know we've talked about before in other classes. So symmetry line is when it cuts it directly in half and everything on either side is equal, which you can tell by the markings is the way it is. Okay. Next, it is also an angle bisector, because it is bisecting this top angle up here. That means that these two angles are equal. So I have a set of base angles that are equal, and now I have a set of angles up here that are equal because this line is also an angle bisector. It also is what we call a perpendicular bisector down here. What that means is it is cutting this line segment here directly in half so that this side length is equal to that side length, and it's doing it, we know that perpendicular means 90 degrees, it's doing it to form 90-degree angles right there. And the fourth and final job is it's called a median to the base. Now, if you think back to driving, median means the middle of a highway. Well, median means middle of the base. This is literally what it means. Remember, your base side is the non-equal one, so it's become a median to our base. Okay, this line will always go through our non-base angle and our base side, and an isosceles triangle only gets one of these lines, but it does do these 4 things. Now, if you notice, there's a lot of things we know. We have equal angles here. We have equal angles here. Equal side lengths, and we have 2 90-degree angles here. So if I were able to give you some measures, you should be able to find all other measures, which is what we're going to do in the homework and do on our quizzes and things. So we will get to that. Now, you may want to pause to make sure that you have all these notes down because I'm going to erase all of this. Now, as we talked about earlier in class, an equilateral triangle is an isosceles triangle because an isosceles is defined as having at least 2 equal sides. Well, an equilateral has at least 2 equal sides. So that means just like the isosceles, the equilateral also gets this line that does all of those jobs. Creates the equal angles, angle bisector, median to the base, perpendicular bisector, symmetry line. But an equilateral triangle gets 3 of the lines. So it gets 3 lines of symmetry that should all meet in the middle at a perfect point if I could draw well. And it gets 3 because there is no non-equal side to call a base. So technically the equilateral triangle has 3 bases. And because it has 3 bases, it's going to have 3 medians to the base. It's going to have 3 symmetry lines, 3 perpendicular bisectors, and 3 angle bisectors here. So all of the properties that follow an isosceles triangle will be trickled down to the equilateral triangle because it is an isosceles triangle. And we've already talked about how each angle is in fact 60 degrees in an equilateral all the time.